This week. I know you do. You don't count. Does anyone have a planner fill out this week? No one?
Hang on. Let me check.
You only need to have 2 entries.
Are you serious?
Wow, they're getting really lenient with this, huh?
I had 2 entries.
Can we like
For this
do
week.
that right now?
Nope.
Not for this week.
Too bad.
For this week. Anyone? Anyone?
But write it down fast. Does it count?
No, I don't have
As
it.
long as you
No.
didn't see
Anthony? You're our last hope. No? Alright, well. None of you get to win anything cool.
What are they even raffling? Oh, we have homework. Not
Listen, listen for your new seats. Okay.
Wait, were these seats assigned?
Yep.
Okay.
So, hold on.
So one seat power each or one for the
No, so you're gonna make sure you know each other's names. What's your one superpower? If you could have any one superpower, what would you have? Probably include a watch. Okay. And then as a team, come up with your team name. What?
Do you have a superpower that allows you to have all the superpowers?
No. Okay. At your tables, ready, set, go.
Okay.
We'll usually be starting a new section in our notebook. So the last part of your notebook should be your review. Told you guys after your test that your review should be in your notebook. Okay, that lower, the bottom left, right here, copy.
I will just break this one in half.
If I see your phone again, I'm taking it, Kate.
You don't even get technical with me. That's what I said. I can play people on my own games. No.
Okay? A few things are going to happen. First, we're going to make a little tab. Okay? So, on the non-sticky side, you all have sticky notes. On the non-sticky side, I'm going to write A1 solving equations. And I'm going to use that so that I can make a little tab. Okay? So that when I have my notebook closed, it'll be a little tab. Okay? So make sure you put that in there. And then put your progress sheet on top of that. Well, or whatever. You can figure it out. Believe in you. It doesn't have to be tucked underneath. A1 solving equations. Okay, so I should have my little tab. I can also say this is my progress sheet for A1. Solving equations. And once I have that done, I'm also going to update my index. Okay, so notice I've been keeping my pages numbered this whole time. I happen to be on page 45. So I'm going to flip to the front, back to my index, and I'm going to say that A1, solving equations, for me, is on page 45. So we have our index updated, got our little tab going, got our progress sheet in there. Arcane, you can get going. All right, are you guys ready? Everyone's okay? So real quick, we've talked a little bit about this. This should mostly be review, but I'm just going to remind you about my guidelines for solving in case you've never heard them from me. Okay? So you've heard about solving before. All of you are capable of solving equations. I've seen already that work from you. Some of you are at different levels, right? That's normal. So here's a few things, guidelines for solving that I expect. 1, show all steps. Show all steps. 2, keep your equal signs lined up. 3, that was a jump. 3 is a silly one, but it's a big one. Box your answer. Ooh, no, circles are terrible. Just kidding. Yes, you could circle. Okay, and 4. Look what I did there. Relating to the kids.
Cool kids do.
All right, you're right. I couldn't do it. Check your work. Huh?
Original is yogurt.
No, it's you.
It's your, but you have an accent over it, so be yogurt.
Okay.
It's people say it.
Those are the guidelines for solving. Every single time. Listen. Here's why they're the guidelines. Here's why they're sitting here right on the very first page of A1. So every time you open to A1, boom, those 4 things. I'm not even talking about how we solve yet. These are the 4 small details, mathematic communication pieces that we need to keep in mind. We're going to do one quick, easy example, just so it's clear, okay? When we're trying to learn how to communicate mathematically, that's what solving equations is. Let me remind you, you all already know how to solve equations. You all already are very smart and intelligent people. I have seen this from you already. Okay? What happens is some of us, when we start trying to solve equations, have a communication breakdown. Kale, don't talk while I'm talking. Okay? We have a communication breakdown. That's what we're trying to get through. In the beginning, because we're having communication breakdown, you're just going to try and mimic my communication, which means that the way I solve equations is going to be the way that you solve equations. Okay? So let's do one quick example so that you see all the guidelines happening. Solve for x. I have the equation. Let's get snazzy because we can. I believe in us. 3x plus 5 equals. If I wanted to solve this equation, it's just a random equation. Has no real meaning to us right now. I just made it up. Okay? Purple or blue? Okay. If I want to solve this equation, there are some other things about solving that we'll work on, blah, 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 just to show us all what it looks like, and so we have a nice, beautiful example. I need to bring the x's on one side, and I need to get the numbers on the other. So, how do I move this x to the other side? Patrick.
You minus x from the side?
Minus x, because I'm always going to do the opposite, always and forever. Okay, so I subtract, and I subtract. You'll even notice that I show my work in a different color. You don't have to, but at least when you're following along, you'll be able to see like where my steps are versus where I'm rewriting. Make a step, I've moved the x to the other side. 3x minus x is 2x. The plus 5 is still hanging out. The x's, right, the whole point, x minus x is gone. I'm left with nothing, and I have that's equal to 19. Yes. Yeah. Because why? Now what's my next step? Minus 5, because I'm trying to have the x's over here, move the numbers to the other side. Subtract 5, subtract 5. I'm left with 2x equals 14. Notice my equal signs are staying lined up. Maybe they're not perfect, but they're pretty stinking close. Last step, divide by 2. I'm showing all my work, I'm showing all my steps. I know to divide by 2 because the opposite of multiplying is dividing, and again, this is a game of opposites. Okay, so 2x, 2 divided by 2, again, the whole reason, what's 2 divided by 2? What's 2 divided by 2 is my question. Is this going to be an issue? 2 divided by 2. How many 2's go into 2? 1. And we're trying to make 1's cancel each other out. 2 divided by 2 is 1. It's just 1. So we're left with 1x. And here's a little invisible piece, right? For some reason, when we multiply by 1, we stop writing it. I'm multiplying. This still says 1 times x, but I know that 1 times anything is that anything. It doesn't change it when I multiply by 1. Okay, but 14 divided by 2 is 7. Equal signs are lined up all the way. Answers in a box. Okay, my equal signs are going straight down the whole time. They're lined up. I have a box. It looks nice. All is well. Now, am I done?
No,
Check
because
your
you have
work.
to. Bob, may I answer this time?
Jolie, I did. Check your work. Check yourself. How do I know if x equals 7 is the answer? What will happen if it's the answer? If it's right, Patrick, what happens?
If it's right, it will be it will come down to a equal number on both sides.
Cool. If it's right, if 7 is the right number, it means this will be a true statement or a true equation. Or the way Patrick said is you'll get the same thing on both sides. So if I plug in 7, let's do it. Plug in 7. I have 3 times 7 plus 5 equals 7 plus, no plus, plus 19. Okay. Now, here's the interesting piece. Now we're just checking. Just like regular multiplying. We're not going backwards anymore. We're not doing weird things anymore. What's 3 times 7? 21 plus 5. This is really a question mark. Is that equal to 7 plus 19? 21 plus 5 is 26. Question mark. 7 plus 19 is also 26. 26 equals 26. Well, bam. We're good.
You have so much enthusiasm.
Okay. Now, just so we're all on the same page. Okay? Back to what I really want to think about. Just so now I can get that off my chest that I've told you my guidelines for solving.
Keep passing it to where there's no one sitting. You can't.
What? What are you talking about? Chill. I'll tell you about the test when I tell you about the test. Thank you. Quick, do A and B. Quickly, like look at each other, show each other your paper, look. Oh, you wrote yours backwards, or oh, you don't have parentheses, or oh, you don't have a comma. Show each other your work. Henry, A, what's the x-intercept?
-1, 0.
Yes? He said -1, 0. Anyone want to second that?
I second the.
Well, I know you, hopefully you're at the same table. You guys say yeah? Cool. X-intercept is -1, 0. Yeah, I agree. What's the y-intercept? 0, 7. Beautiful. Okay, again. There's my y-intercept. There's my x-intercept. Yes, you might know, we've talked about this before. Okay, on my graph. Okay. When I'm looking here at my x and y-intercept, we should hopefully be pretty comfortable with knowing which one's the y-intercept, right? Because that's how we've been talking about with graphing. On my y-intercept, Arcane. How do I write it for my y-intercept? Nice. I agree. What x-intercept over here?
2, 0.
Nice. 2, 0. So when we're looking at these, like when I'm looking at the two x-intercepts here, two different graphs, doesn't matter, but I'm looking at these two. And we've talked about this before. For my x-intercepts, what do they have in common? What do they have in common, Omar? Huh? What do the x-intercepts have in common? 0 where? On the y, not the y-intercept, on the y. Okay, on the y-coordinate. The x-intercept occurs when y equals 0. In order to solve for the x-intercept, you plug in 0 for y. Okay, x happens when y equals 0. We've already looked at this a bit, but it's like huge idea, huge. You might think right now, like, it's not that difficult, Ms.stolte, but then later I'll be like, remember the x-intercept? You'll be like, oh. Okay. Sorry. I watched him stand up last night, and then you know that like jumps into your head, and you're like, that was funny. No?
Yeah, you can have to get, now you can stand up comedy. I wish math was stand up comedy.
I'm trying. X-intercept when y equals 0. The y-intercept occurs when then? When? Yeah, when x equals 0. In order to solve for the y-intercept, you plug in 0 for x. Okay? We are going to talk about two examples. I'm going to make them hard examples because I feel like it. If I have something like this. I don't know, 30. If I have that example, 4x plus 5y equals 30. Fun fact, I'm just going to tell you. I'm not going to make you write it down. This is called standard form of a line. Has anyone ever worked in standard form? Groovy. Cool. You're a good math teacher. This is called standard form of line. You don't need to really know that. I'm just throwing it out there. If I want to solve for the x-intercept, stop talking to Arcane. That's on you, Kale. I'm not even looking at Arcane. Don't talk to him. If I'm solving for the x-intercept, what do I do? Plug in 0 for y. It would look like this. 4x plus 5 times 0 equals 30. What's 5 times 0? 0, right? This just makes a big fat 0. What's 4x plus 0? 4x, right? When I multiply by 0, I get 0. When I add 0, nothing happens. It's called the additive identity. But again, you don't need to know that. Okay? 4x plus 0 leaves me with just a 4x equals 30. Right? So I'm going to move that back up here. If I am trying now to solve, and I have that 4x equals 30, 4 times x is 30, what's the opposite of multiplying by 4? Divide by 4. So I divide both sides by 4, divide both sides by 4, and I get x equals 7.5. My thinking noise. And this means, look at me writing a sentence. The x-intercept is 7.5, 0. Huh? You're lucky, I was going to kick you.
Somebody get kicked out then?
Now you get kicked in.
Somebody get a kick out of that?
Next one. Guess what? Big surprise here. I'm not going to do this one for you.
Oh boy.
Do it quick, like a bunny, real fast. Solve for the y-intercept. Solve for the y-intercept. Notice you're solving, so it's looking good. Anytime I say solve, those 4 guidelines apply.
In the center.
Okay. You ready?
1 sec. So you said 5y.
You're gonna solve it? Yeah, but he already is talking too much. Yeah, I know, I'm talking too much.
5y.
It's okay, Xander. I had the same problem when I was in high school. Teachers never called on me either. Okay, last thing I'm gonna say for a few minutes.
Teaching with young mind.
I know, good. Teach him in a second. What do I do to solve for the y-intercept? Yahi, what do I do? 4. Yeah, for the y-intercept, I was going to do it wrong. I plug in 0 for x, so I put a big 0 right here. What's 4 times 0? 0. Don't say 4. 4 times 0. This just disappears. Just disappears right there. Just gone. Done. And then I'm left with this. I'm left with 5y, 5 times y equals 30. Again, little invisible trick. We don't write the multiplication sign. Mathematicians are lazy, which is why I think high schoolers should love math, but we don't. Okay. This is 5 times y. Opposite is dividing by 5 on both sides, always and forever. And I get y equals 30. Just kidding. Y equals 6. Boom. Which means then the y-intercept is 0, comma 6. Boom, shakalaka.
Real life.
I don't know. But it still reminds me of my very first year teaching. That's
What was how does it remind you of your teaching?
because you're trying to get me off task. Because I used to say boom shakalaka sometimes, and I had a student in my class. He was great. He had Down syndrome, and he would always, every time I said boom shakalaka, he would say, no, Ms.stolte, it's fart shakalaka. I was like, you're crazy, and I love it. It was good. He was a doll. Yeah. No, that's the only one to get today. In his memory. Okay. You'll notice if you like hopefully should be able to see what the y-intercept is from here. Why is it negative 6? No, because what? Why is it negative 6? Yes, because that's where it starts, and using our newfound knowledge, hold on, don't say it's because it's mx plus b. It's not mx plus b like randomly. Look up here, look. We all know already the y-intercept is negative 6.
Yes.
Because what, Xander?
Because and because it already said it.
No. How do I get the y-intercept?
So you do that.
No. How do I get the y-intercept?
Plug in 0.
Plug in 0 for what? X. So if I do 2 times 0, what do I get?
Y equals negative 0.
Yeah, it just tells you, hey, shh. The reason it's negative 6 isn't because mx plus b is some like magical formula. Okay? That whole mx plus b business is only because when you plug in 0, your x goes away. Because 0 times anything makes it 0. Okay? So as soon as we can start connecting that and recognize like it's not just a magical formula, it's because of how we find the intercepts. Okay, so solving for x and y intercepts. I'm going to look at parte B. Part B. Y-intercept. Yeah, you know it. The y-intercept on part B. The y-intercept on part B. You should already know it. Look at it. Look with your eyes. Look. What's the y-intercept? 2. I already know. I could really quickly show it. 1/3 times 0 plus 2. The y-intercept is 2. Okay. X-intercept is a little bit of a different story.
Is it supposed to be a negative number?
No say. Hold on.
What?
Not telling.
If I want to find the x-intercept, I need to do what?
Plug in 0 for y.
Plug in 0 for y. So I would get this. 0 equals 1/3 x plus 2. Here's a quick note about equal signs. They're really powerful. The best. It doesn't matter for some reason, for whatever reason, because this has been drilled into your head. You guys get a little bit confused sometimes with this. Not you guys, I mean students in general. You get a little bit confused by that. I can move this equals 0 to the other side. Okay, I can just write the equals 0 over on the other side. Because it really doesn't matter. So if I move the equals 0 to the other side, a lot of us feel a lot better about solving it now. Okay, if I move the equals 0 to the other side, now we feel a lot better. Okay, so now I go about solving this. Stop with the puzzles, Xander. If I go about solving this now, I'm trying to solve. I know to subtract 2. I get 1/3 x equals negative 2. It's the same thing as before. 1/3 times x is negative 2. What's the opposite of multiplying by 1/3? Dividing by 1/3. Now, it's not necessarily the best way to write it, but we can write it anyway. Because it's just a number. You need not be scared of fractions in here. If I want to do negative 2 divided by 1/3, I always put parentheses around my fractions. So here, if I want to do negative 2 divided by 1/3, I have negative 2 divided by parentheses around my fraction, negative 2 divided by the fraction 1/3. Boom. You get my answer of negative 6. Okay. These are some small tricks